Hi, in this video, we will discuss about normalization for relational database design. First normal form. A relation is said to be in first normal form or 1NF if the values are of same domain and the columns have unique names. Order of data stored does not matter and it has single or atomic valued attributes or columns. Let us consider this particular example. So we have three columns or three attributes: employee ID, employee name and qualification. So the first condition, values are of same domain. In the sense, here, this example, all employee IDs are of type integer, employee name are of type string, and qualification are of type string. So there is no mix of variables. The second one, we should have unique names. Yes, we have unique names. The order of data does not matter. Yes, the last condition is it has single or atomic valued attributes. But if you consider here, this is multiple valued. In the sense, for a qualification, we have given two values. Or you can also imagine for one person, you have two mobile numbers. In that case, we say they have not atomic. So this particular table is not in 1NF. So what you have to do, you have to bring it to the first normal form. Let us try the first one. We'll use multiple rows. So we divide the tables into two, like 102 current MSc, 102 current MCA, like that. We can make two rows to represent this. Or here you can go for one more representation, like you can add one more column and you can add it. But the question is here, if we are adding like this, why only for 102 and 103 two rows? Or here the question is, why only one qualification for 101? Like that you may have some questions. So let us go for the next way of representation. So what we can do is we can divide the table into two, like employee ID and employee name in one table, employee ID and qualification in the other table. So in this case, we don't face any problem and also the data will be organized. So whenever a particular table is not satisfying the relation, we try to divide the table into two or more subtables. So here it satisfies our first normal form. So first normal form will create single valued attributes, that is atomicity, but the drawback is it will left with data redundancy. So first normal form means atomicity or single valued attributes. So let us discuss second normal form. So a relation is in 2NF, that is second normal form. If it is in first normal form and every non-prime attribute is fully dependent on each prime attribute, that is no partial dependency. So here prime attribute means attribute which is part of a primary key, and non-prime attribute means which is not a part of a primary key. Let us consider this particular example. We have a list of attributes and here we have a few functional dependencies, that is functional dependency 1, functional dependency 2 and functional dependency 3. That is project title, project manager and project budget is functionally dependent on project number, whereas employee name, department name are functionally dependent on employee ID, and whereas the hourly pay is functionally dependent on project number and employee ID. So we have three functional dependencies. So we say that the non-prime attribute. So prime attribute means which is part of a primary key. So here the department name and department number depends only on employee ID, not on both the primary keys. Primary key is project number and employee ID are primary key, but there is partial dependency. It is not, the employee name is not depending on the project number. It depends only on employee ID. So we call it as partial dependency. So to avoid this, we go for split the tables based on the functional dependency. So we get three tables, one a project, the other one is employee department, and the third one is project employee. So this will satisfy your second normal form. So second normal form means there is no partial dependency. Single attribute primary keys are created, foreign keys are created, and it also suffers from update anomaly. So second normal form means no partial dependency. Let us discuss third normal form. A table is said to be in third normal form if it is in the second normal form and it does not have transitive dependency. What do you mean by transitive dependency? If you consider an attribute A, B, C and there is a dependency like B is functionally dependent on A and C is functionally dependent on B, then C is functionally dependent on A. Then we call it as transitive dependency. So we should not have transitive dependency, then only we say the table is in third normal form or 3NF. So let us check with this example. So here employee name, employee number and department name. We say the department number is functionally dependent on employee ID. Similarly, department name is functionally dependent on department number. So now we say that department name is functionally dependent on employee ID. So that is B is dependent or functional dependent on A and C is functional dependent on B. So C functional dependent on A. That is what we call it as transitive dependency. So non-prime attribute dependent on non-prime attribute means then we have to go for divide the table into two. So we get two tables, employee with employee ID, employee name and department number, and department with department number and department name. So in third normal form, a non-prime attribute is functional dependent on non-prime attribute, that is not allowed. So we just go for divide the table to break the transitive dependency. So third normal form means no transitive dependency. There is a special normal form. We call it as Boyce Codd normal form, and even we can call it as 3NF normal form. Here it is a special normal form. Here if the table is said to be in BCNF, it must be in 3NF. For each functional dependency x tends to y, x should be a super key. It means no multiple overlapping candidate keys. Let us see what it is. Consider this particular example. We have two primary keys, a set of attributes, not two primary keys, set of attributes. Student ID comma subject is a primary key. And here multiple professors teach the same subject, like Anil and Karthik teach Java, but you can also note only one professor teaches one subject and professor depends upon the subject, not on the student ID. So we say that here we have a multiple dependencies. So to break this dependency, the primary key is depending on non-primary key. Because subject is a primary key, professor is not non-primary key. In this case, we just go for divide the table to resolve multiple overlapping. We get two tables and we create a one more ID, one more primary key called professor ID, and we divide them into two tables. So professor ID, professor subject, student ID and professor ID. This we call it as Boyce Codd normal form. Voice code normal form means no multiple overlapping of keys. It is also known as 3.5 normal form. Let us discuss the advantages and disadvantages of normalization. The advantages are it reduces data duplication, groups the data logically, and also enforces referential integrity on data. But the disadvantages are it slows database performance and requires detailed analysis and design. And it creates a number of fragments. In some cases, you have to go for denormalization to achieve good efficiency. So we have 5 normal forms. Out of this, any table you design for your project or for your work should satisfy at least 3 normal forms for a good efficient access. So you can refer Fundamentals of Database Systems by Elmastry and Nawate for more information. Have a nice day.